service going on this thing, sir? I'm doing this part right here. Just
Thank
give me just a second, because I have to. There it is.
Brand new season.
So, alright. We're gonna, for those of you gentlemen, there's nothing up my sleeves, 'cause I'm not wearing it. We're going to, we're gonna watch, so we're gonna pretend that. Take this off. Rim up here. Clamp. Yes. Oh, little clamp. Those are the days. We're gonna clamp. Great. We're going to not sew the flaps. Down here. Down here. There. We're gonna put it about there. We're gonna bring our belt stem around. Belt stem around. So if you notice everything's moving, right? I moved the upper roller, moved the lower roller. We're gonna set this location. And just for you guys in the cheap seats, we're gonna bring the lower roller out. We're gonna move the lower roller up and down. We're gonna take the upper roller up and down. We're gonna take our mount head and move it. We're gonna take our pusher arm and move it. Right? So now I'm ready to demount this tie. Okay? Now, so I proved to you that all four arms in whatever way they need to move. Okay? Nothing is being stopped from moving. Right? I didn't put in a mechanical limiter on anything. Okay? So we're gonna hit the demount button. And all we get is that wonderful error message that she's not getting because he's focusing on me instead of the error message. But that's fine. So we have a wonderful error message. So I'm going to do it again. Okay. So in the middle of the screen there, that's where the machine will always talk to you if there's an error message, right? In the lower left-hand portion of the screen is where the machine's asking you to do something to make sure that the tires are, we're verifying that the beads are broken, stuff like that. So if you notice, there's a wonderful error message. Did anyone actually get to read it yet? Because it's pretty quick.
Arm stall at pump relief.
Arm stall at pump relief. That's great. How many arms do I have? 4. How many axes do I have? 8. Technically 7, but we'll go to 8. Right? So arm stall. What does that even mean? That is the most wonderful engineering phrase you'll possibly read today. Arm stall at pump relief. Does anyone want to take engineerese and turn it into English?
The arm didn't move out.
When
We wanted it.
So close. So the arm failed to move. The pump ramped up to all the way to max pressure until the pump made so much pressure it hit the relief valve. So arm stall at pump relief. That makes perfect sense to an ME probably, or an HE, a hydraulic engineer. I think those are still MEs, right? So too many E's. That's perfect English. Why doesn't everyone understand that? What's wrong with us? We're idiots, right? Because we didn't go to college for 8 years. Anyway, so the arm could not move. the pump made its maximum amount of pressure because the pump's like, dude, you gotta go. And the arm's just like, I ain't going nowhere. Okay, so that's a wonderful, wonderful, the problem is how much help is that? You're allowed to say zero because that is zero amount of help, right? I have no idea.
Brief, very brief.
I have no idea what arm didn't move. I have no idea what arm didn't move in what direction. All I know is that somewhere on this lovely machine there's an arm that can't move and the pump's on there. Okay, so what you guys can do, we're going to go into service mode, right? So in a balancer or a tire changer, all of the, and on a brake blade with a tablet, all of the really intense setup questions are behind the password. Okay, that's one thing between Winalign. Winalign, because it's Windows, the normal operator, the technician can get into all 40 or 43 setup questions and can wreak a general amount of havoc until you have to figure out how to reset defaults. Over here on a balancer or a tire changer, we don't want them to do something that could hurt them because, there's things spinning, things moving. There's, like on here, there's crash avoidances and there's things return. So we put it behind service mode. So to get to service mode, we're going to go to utility, and then right here on the second, these are all just drop down menus. If I go to utility and then I go down to the bottom here, right now it says leave service mode because I'm already in service mode. So the bottom button would normally say enter service mode, and then you would enter the super top secret password that's been the same super top secret password for like 30 years that everybody knows. Okay. So Eco service. Okay. All right. So you would type in Eco service. And then if you notice on the bottom, underneath the tire, in the middle of the monitor, it doesn't say Hunter Engineering in white. It says service mode in red. Okay. So the good news is if you just touch the word service mode, it takes you out of service mode and it sends you back to Hunter Engineering in white. So you don't have to do the menus and you can just hit the button. Okay. So I'm in service mode because if I want to do any sort of diagnostics, I need to be in service mode, right? We don't want the end user doing diagnostics and, sometimes when you're in diagnostics remove some of the safeties, right? And the last thing we need are your compatriots who aren't as smart as you getting into places where there are no safeties in place. Right, so we try to keep Darwin at bay as much as we can. We relatively do a good job most of the time. So I'm in service mode, so I'm going to go to diagnostics. So if you notice under utility, there's the word diagnostics. And now we have several different, we have several different things we can do. Okay, we can do a lot of things. So let's just say I want to do detailed diagnostics, right? Because I'm in diagnostics, but I need to, I just don't want to, I want to do nitty gritty diagnostics. Okay. If you notice right there on the bottom, it says factory test, and factory test sounds like ooh. All right. So I'm going to click on factory test because all the other ones are, if it says joysticks, pedals, spindles, and arms, right? So I would guess that I would go somewhere in arms because it said arms stall, but I don't know which arm to deal with, right? So factory test sounds like it's going to test everything on the thing. And lo and behold, there are 46 different tests that the factory test is going to run. So I'm just going to tell it to run all the tests because I have no idea where I'm going, right? So I'm going to step on the go pedal here. And then if I step on the go pedal again, absolutely nothing happens. And it didn't even give me an error message. That's impressive. So let's just say I thought I messed up. So I'm gonna run. I'm gonna re-click run all selected tests. Okay. And then we're just gonna do it again. That was about as helpful as me cooking supper. I I mean, there is not a lot going on there. Not even an error message. So, unfortunately, in this particular failure, factory test didn't do us any good. It does a really good job in other things. Like if you're just trying to get a general overview of the machine, like this is your first time walking up to it, and the guy's like, every fourth tire it moves to the left instead of to the right. So whoever has NFC on their Samsung phone, please turn it on. You keep trying to communicate with my TV. Anyway, and you're not going to make a payment through it in the next 8 hours anyway. So it's probably me. I probably have NFC on. I know it's an arm, right? So I'm going to back out of factory test because factory test didn't really do me any good. Unfortunately, this one didn't really work well. So the very first one's upper bead roller, right? So I don't know which one of these 4 arms to test. So let's run all the tests again. We're going to run all the tests. If you notice, since it's just the upper arm, there's only 17 tests. So we're going to say run all tests. All right. The good news is I finally get an error message, and it's like, hey, there's a problem with the pusher arm. So at least now I know which arm I'm dealing with. And the testing apparatus actually says, hey, would you like to move to pusher arm diagnostics because you're in the wrong arm? And that's helpful. So we're going to say yes. So now we're in pusher arms. So now I'm going to run all tests. Okay, now there's only 8 for the pusher arm because it doesn't do as much as the rest of the arms. We're going to go. Okay. Error. Press diagnose failure for more information. So we're going to hit, hey, look, there's a button that says diagnose failure. All right. It says arm failed vertical home test. So it's telling you that the arm didn't go home. It failed that part of the test. So evidently, the machine was trying to take the pusher arm here and push it higher. But the arm didn't go anymore. Probably because the arm is stroked out and there's no more, it reached its limit on the hydraulic piston or hydraulic cylinder, so it physically can't go anymore. It says, no movement detected by the vertical potentiometer. Again, because the arm was up as far as it could go, it can't go anymore, but the potentiometer was expecting to see movement because it was trying to go home. Okay. It said, did the arm move vertically? I didn't see it move. Anyone see it move? No, we're going to say no. Press go and watch for vertical movement. Yeah, it didn't move. Okay, so it says press go and watch for vertical movement, and then it says so the machine has diagnosed itself with a bad directional valve. We'll get into directional valves in a minute, but basically, if I have a cylinder and it's hydraulic, I have to have some type of valve to move the fluid either to the left or to the right, so that the hydraulic piston can either collapse on itself or expand, so that the arm either comes down or moves out. Right? Makes good hydraulic sense. All right. So watch. This is the best. Watch this. We're going to do this. We're going to hit OK. So it's going to give you a 3D model. It highlights which directional valve that it thinks is bad. Then it's going to tell you where on the power outs board that hydraulic valve attaches to, right? That is the most disgusting display of 3D CAD model flyby I've seen in a while. Wasn't that really cool? Now, that's so cool, I'm going to view it again only because it makes me smile. Okay? Right? And when we get to see those valves, guess what those valves are going to look like? They're going to look just like that. I mean, that is a very good 3D model. Okay, let's just say you don't have a valve on the truck. What could you do? Swap. You could swap it with another one, right? Because it looked like there was 8 of them right there, and all 8 of them looked exactly the same. All 8 of them are the same.
Doesn't tell you the part number.
It doesn't. We don't like it that.
That's an expert.
We don't like it. So, okay. So basically, it thinks that. Now, normally this test is good, but I purposely choose this failure every time just to prove a point. Obviously, there's nothing wrong with the direction valve. You didn't see me move the direction. You didn't see me unplug it. You didn't see me touch the direction valve, right? So, what we're going to do instead, because I like to prove this to a point to where you guys really believe me. Although someone's already been out once on a call and the dude hit tools clear and you followed the error message on the screen. I forget who it was. So, whatever tools clear says, do it. Okay, so I'm gonna hit reset. All I'm gonna do is hit tools clear. How's that for an error message? That was a much more concise error message, right? Because, so this error message says, the pushers are not returning home. Vertical axis suggested service. So, all of a sudden I went from 4 arms in 2 different directions to 1 arm and it told me exactly which direction it went in. Oh, I couldn't have told me that before. So, tools clear is by far your best diagnostic aid on a revolution traction, right? It will always tell you what is potentially failing. Okay? So, now I know where to look. I can forget 7 other Hall effect sensors. Now I can look at the pusher arm vertical potentiometer. Okay? So, we're going to go back to utility, and we're going to go into something called data display. Okay? Which you have to go into diagnostics, and then you can go into data display. Okay, now data display. Okay. Data display shows you every position of every potentiometer on the machine. So that's why the home position is the most important, because all the other numbers are just greater than the home position. And I have no idea what 2 inches down and 2 inches over is, because it's technically going to vary from machine to machine by a couple of counts, because the home position is going to vary just a little bit, right, from the machine. Because everything's electronic. You got potentiometers, you got resistors, you got blah, blah. So anyway, so we're going to look at number 9. I believe it's number 9. We're going to look at number 9, and it says press arm vert, okay, which stands for press arm vertical potentiometer counts. It's just counts. Okay. So your problem is, it says 4 something, right? 405, 409, 405, 403, 403. Great, now you know what it is. Problem is you don't know if it's good or bad. Right? You don't know what that number means. Okay. But if you notice, like 1, 2, 3, 6, 1, 2, 3, 4, and 6 are all in the 300 range, and 9 is in the 400 range. So you can surmise, being a relatively intelligent person, probably should be in 3 somewhere, but you still don't know where it's supposed to be. So we're going to end this test, and you have to be careful here. Okay, we're going to go. It's weird, you have to go back into utility because you can't go from diagnostics to calibrations on the same screen. Okay? We're going to go to calibration procedures, but we are not going to calibrate anything. You have to go to calibration procedures to see what the stored values of the last calibration is. Okay? That's why I'm scared for you, because you guys recalibrated something without the magical unicorn juice, which probably tells me that you calibrated it, and I'll explain in 5 more minutes why that's wrong. So, calibrating something without fixing the underlying problem is like paving a road without filling in the potholes, right? You make a nice new smooth surface. What happens 2 weeks later after that new the pothole shows back up because the asphalt sinks into the hole. It looks good for about 2 weeks, and then the underlying problem shows up again. Okay, so that's why the first thing out on a revolution should never be let's calibrate it. The first thing on a balancer should never be let's calibrate it, because when you calibrate it, you just paved over all of your problems and you have nothing to use to help you diagnose anything. In the end, you might have to recalibrate, but in the beginning, so we're going to go to calibration procedures. We're going to go to arms because I know I need to go to arms. We're going to go to the pushers because I know I'm going to go to the pushers. And then what I'm going to do is I'm going to go show cal results. And then if I want to be even weirder or a bigger nerd, I can show previous cal results. Okay? So now I have what? Just ask.
No, I was telling them I'm gonna transcribe all this and go.
Oh yeah. So that's cool. So deviation.
That'll transcribe.
Right. So if you notice here, vertical home. My vertical home was calibrated at 300 on 1028, and it was also calibrated at 300 on 825. So the last two times this thing's been calibrated, my vertical home has both been 300. My live vertical counts is 400. So what's trying to happen? Let me ask you, what's trying to happen?
It's trying to push it to 300.
It's trying to push it up to 300. What's stopping it?
It said it's the physical.
Yeah, the physical limit of the hydraulic piston or cylinder. It can't go anymore because the hydraulic cylinder is only so long and the track's only so long. If it wanted to go to 300, it'd probably have to push it off the top of the machine, which would probably be bad because it's really heavy. So keep going here. How did I get from 300 to 400? Okay, that's what most people said. That's what I said until 2013 to 2017. That's what I said, right? I got a bad potentium.
What could his position?
Tom told you to get 14 and 14. Take it to the perfect. Walk into his office at some point, and you know how we the last couple of ADAS links had to do a double update. It's on its second of the double update in his office. The first update went through last night. This morning we started the second update. So at some point it should get done.
Yeah.
And then that'll go to the teacher. Okay. So sorry, I heard scurrying. So yes. So from 2013 to 2017, I was out in the field, and I was probably the best potentiometer replacer on the planet. I mean, I had that down. I was replacing 2 or 3 potentiometers a week, right? Because that's what we were doing. Because we bought, some potentiometer from Malaysia, where they were putting it together in the dirt. It was like either that or the other term we were using is if the potentiometer is geared into a track, what is the other thing that could happen? It can skip teeth, right? So what I do is I look at the pot, and I'm looking at the pot. The pot looks good, and I have all my teeth on the pot, and I'm looking at the track, and I'm like, somehow it must have skipped teeth. I don't know how it skipped teeth, right? I don't know how it skipped. So I either have a bad pot or it's skipping teeth. So I take that potentiometer and I unplug it, and I take my new potentiometer and I plug it in, and then you can take the housing it's in is made out of an interesting type of plastic that it's like spring tension plastic. You can sort of push it out of the way enough that you can spin the pot. You can spin the pot. You can spin the pot back down to about wherever it needed to be. So we're going over here, and I know I need to spin that pot to 300. I'm going to take the new pot and I'm going to spin it to 300. Okay. So I'm done, right? I replaced the pot, calibrated the pot. I got it to 300. It's good enough, so I built for calibration. Go ahead. You have a question?
Can you guys ever run into like high resistance on these?
Thank you. Hold that. So, what happened 6 weeks later?
Does it
Again, right? So now I charge the guy for a pot. What you guys don't know, because I haven't told you yet, is every part that comes off of your truck, unless it's consumable, comes with a 6-month part and labor warranty. So what am I doing? Warranting that out, right? But I can't charge trip charge, I can't charge, labor, and I can't charge for the part, because you guys give, from your contract, a 6-month part and labor warranty on everything that when I say comes off the truck, even if you direct ship it to the customer, if you install it for the customer, it carries a 6-month part and labor warranty. Okay. So, 6 weeks later, here man, we are buying the junkiest box on the face of the planet. At this point, we're not even in Malaysia anymore. I don't even know what country makes worse boxes than Malaysia at this point, right? So, we come in one time for national meetings, and I'll never forget it. I was so mean to Troy, he probably deserved it. So Troy was trying to tell us that, because back in the day, our return policy was much different than the return policy today. Back in the day, we had to return 100% of our warranty parts, which means, we would keep them. We would get this ginormous box, and then we would ship back 20 or 30 RGMs at a time in this ginormous box. So in that box, there'd be, 10 or 12 potentiometers. Because I'm shipping all these pots back because I need them to send me a free replacement pot. Either that pot was under warranty originally, maybe that Revolution tire changer was 2 years old and has a 3-year warranty on the part, right? So I didn't charge the customer for the part because the part was under part warranty, but I got to charge the customer for a trip charge and some labor, right? And the part was free, and that's fine. It's just 3-year part warranty. And then the second time I put the part on, everything was free, right? So now I have like 2 pots from the same place. I've technically bought 2 pots in those 6 weeks. So then what I do is I fill out the RGM and it says, look, I bought the pot. I have a pot. I just need you. I'm shipping the old one back for like credit, right? So I ship the old one back and they credit me for the first one. The second one hits. The second one credits me for the second one I bought. So I'm technically, after about 2 or 3 weeks, I'm not out any money, right? They bill me, but the billing is on that 25-day billing cycle, right? So it behooves me to return my RGMs before the 25-day billing cycle, so that at that point it's all like funny money, right? Like let's just say, for easy math, a pot's $100. So they bill me $100, and then I order one in, and then I ask for a credit, and then they go, okay, fine, we're gonna credit you the $100, and because it's under warranty, they credit me the shipping. Isn't that nice of them? Even if it's overnight. So, I put the pot in. Dude, I need a pot. So I overnight in another pot, knowing that it's under warranty. I'm gonna get everything back. It stinks for Hunter because they're reimbursing freight that they're losing at that point, right? Because UPS doesn't care. UPS is billing somebody, right? But that's how cool our warranty part situation is, right? If it's under warranty and you overnight it, and that's the part that fixed the machine, we will reimburse you for the part and the shipping to you. We will not pay for shipping back to us, but we will reimburse you for the shipping that it took to get it to you. Which, again, you will never find that anywhere else on the planet. So, my problem is 6 weeks later, it's back up at 400. Okay? Go ahead.
So another observation to his point is the horizontal counts are well above your previous as well. So are those potentially on the same reference circuit?
So yes and no, but here's my hitch. My horizontal run by electronics or run by hydraulic?
No, that's in and out. So that's
It's
electric.
in and out. So it's
Air over pneumatic or air over electric.
what's that little silver guy right there? As a linear actuator. And a linear actuator is electric. So when I do tools clear, I'm only clearing the hydraulic portion of my tire changer. So my pushers, unless I physically move my pushers to home, my pushers don't automatically go back to home. But again, my pushers horizontally don't have a potentiometer, right? We're just counting the linear actuator numbers, which is why these are at 61 and 62, because those pushers are way in, and my live counts right now is 300, so they're a little further out there. So good observation, but they're electric and not hydraulic. So tool's clear when he does hydraulic stuff. So we're gonna go back to 33 here. How did I get to 403? Because when I came back in, they told me that 99% of the potentiometers that I turned in the lifetime of my working on this 2013 and 2017 were not bad. Because they would take the potentiometer, they would hook it up to a jig with the rails on it, they would put it at 300, they'd run it all the way down, they'd run it all the way up, and they would say that it wasn't skipping teeth, and that the potentiometer is recorded.
High resistance causing voltage drop to the module, so it can't get.
Excellent. So, high resistance. How do I get high resistance?
Terminal fretting, bad connection.
Yeah, fretting.
Yeah.
Excellent. I love you guys. Terminal fretting, or some people rather than terminal fretting, they like to use a really big term, micro corrosion. I had a guy at a Chevrolet store talk about all of his connectors in this car had micro corrosion. Man, that is a really fancy term that means nothing. But he was throwing that out there for the warranty clerk. The warranty clerk was just eating that up. It was like, ooh, micro corrosion. So
I might steal that one.
micro corrosion. Oh, I love
saltwater exposure, man. That's a
love
bitch.
All right, so airbag systems. What are the pins in airbag systems? They're gold. Why do we use gold in airbag systems?
Superconductor. Yeah.
It doesn't have micro corrosion,
Yeah.
or it doesn't fret, right? Because what happens in a car to all the connectors? They move, right? They just move because the car flexes and things are doing this. So on a regular connector, if they're made of nickel or aluminum or titanium or unobtainium or biercanium or whatever else metal we're using, right? You're gonna get some, because as it moves, it creates static electricity, right? Because it's two pieces of nickel or tin or whatever, so it creates static electricity. Static electricity shows up as resistance, and as the resistance rises, my voltage falls because of P over IE, good old Newton's law, right? So Newton's law, baby. You guys are Newtonian. So yeah. So what we got, and ohms, right? So we could have gold plated all of those connectors, but then it would have been a much higher priced machine, right? So we don't gold plate any of the connectors, right? Which is why your airbags just don't go off into your face, because they use gold plated connectors. So that's why I'm worried for you, because again, so with our Troy, to his credit, he took lots of lumps, and he took money. We were not kind to him. Because I have 4 years of replacing pots, and every time I replaced the pot, they fixed it. So what happened every time I replaced the pot?
You cycle the connector and remove some of the fretting.
Right. I didn't remove all of it, but I removed some of it. And then what did I do with the other bit of it?
Calibrated it.
But I spun it, right? Because when I put the new one on, it may have went from 403 to 350 because I got rid of some of the resistance, but I didn't get rid of all the resistance. So I went from 403 to 350. So then when I calibrated it, I moved it all the way home, moved it out, moved a couple of teeth, got it to around 30-ish, called it a good day. Okay, but I still had by still having some of the resistance there, the problem came back quicker. Like it took 1.5 years for it to get to that part in the first one. But because I didn't get rid of the resistance was already there. So it's almost like freezing hot water versus freezing cold water, right? Hot water will freeze faster than cold water. This one was weird. I don't know. Molecules are moving around. So because I have that built up resistance, the resistance didn't really go away. So during the meeting, he told us to buy a special spray. And of course, it's not here. Dirt bags.
There you go.
That's it, man. Alright, so. Now you shook it up, now it's all fizzy, now it's gonna explode. No, don't touch that. Alright, so he told us to buy this special spray. This spray is actually called a multi-purpose precision lubricant. Okay? And so what the engineers figured out is they can't stop the pins from moving, but if we spray this lubricant in between the pins when the pins move, it's almost like dielectric grease. The pins aren't touching each other anymore because there's this thin layer of, you could almost call it like engine. There's this real thin layer of lubricant on it. So when the pins move, they don't create the static electricity because the pins aren't actually touching each other. The lubricant is keeping the static electricity at bay. Okay. So, of course, I didn't believe him. But Home Depot. You go buy this at Home Depot for about $4.75. It'll last you and your kids to your grandchildren. Okay? Everyone always asks about dielectric grease. When I show you how small the female ends of the pins are, there's no way you're stuffing in dielectric grease. You'd have a better chance of trying to do a wheel bearing in your hand the old-fashioned way, trying to get the grease to shove out through the top. Okay? So this is much easier because it's a lot like WD-40. It doesn't conduct electricity, so you can unplug it, you can spray it, you spray both ends, and you can plug it right back in immediately because I don't have to worry about it screwing up any of the electricity. Okay, so I'm at a place and I need to put in a pot. I look to the left, I look to the right, and nobody's watching. And I look to see if the blue light's on and the blue light's off, so I know Hunter's not watching. So of course I run out to the van and I sneak it in my shirt and I spray it and stick it back together. Holy cow, that worked. Right? I'm never going to admit to anybody that I used it because, you know, that's crazy. Put on my tinfoil hat. The problem is I didn't realize something at the time, but was I spraying enough? So the potentiometer has a little pigtail, and I was spraying the potentiometer in. The other end of the cable. Now, this is where it gets me. Sometimes I can be very linear. What does the very other end of the cable connect to?
Board.
A DAQ board. Okay? So in my head, the DAQ board is mounted to the machine. So how's the DAQ board move? Right? The DAQ board is hard mounted to the physical frame of the machine. Vibration and oscillation, because what I didn't realize at the time is the DAQ board, which I'll show you guys in a little bit, the DAQ board is about a foot above the motor. Now, the wonderful thing about this motor is the people who made the revolution didn't talk to the people who made our lift racks. And the motor on a lift rack is rubber isolated, right? Guess what they did to the motor on the revolution?
Hard mounted.
They hard mounted it. Because why would an engineer ask another engineer? Because these engineers are smarter than these engineers. Right? If you're the engineer, you're smarter than the other engineers in the room. So why would I ask the rack people, how to put a motor on something, right? What do they know? They're rack people. So every up until today, and if they're making a revolution today down in Mississippi, guess what they're doing to that motor?
Rubber ice.
No, they're hard mounted. Are you kidding me? You think they fixed it? Do you know why they didn't fix it?
Pride?
Because you know how to fix it.
Oh, because we can
Right.
fix it.
Now, what's a good engineer do to a workaround? Turns it into the fix. Right? Does he fix it? No, because there's a workaround, which means he doesn't have to fix it because you'll fix it for him. Right?
So
And
Hunter
he
will just
doesn't have to re-engineer the part. He doesn't have to come up with longer hoses or a longer wiring harness. He doesn't have to come up with a different mounting, to actually put rubber isolators in it. Because now, anytime I don't know if that's good or bad, but anytime Hunter Engineering comes with a workaround, that is automatically the permanent fix for whatever we're doing. I shouldn't say always. You never say never, you never say always. But a vast majority of the time, if we come out with a service bulletin that says this is how the workaround works for this, that is now the accepted fix. Okay, so I wasn't spraying the other end of the cable going into the DAQ board because my puny mind didn't realize that that DAQ board was oscillating because the motor was hard enough. So I still had some problems because I was still getting the counts going back up because I took care of this end, but I didn't take care of that. Okay. So for those of you, I don't know if you took a picture or not. So this is, and it's a little sticky, and I apologize because other people have touched it, used it, sprayed it. We actually got to use that on a foot pedal in ops because my foot pedal was out too much from 1800, and Dave and I, the guy that you guys have never met but I keep pointing to, we actually used that on a foot pedal potentiometer, and it brought that number exactly right back down to where it was supposed to be. And I've used it at home too, so that's why I'm concerned because Jaden didn't say anything about that.
So, and this is the other rep, this is his.
I get it. I get it. Well, it's your problem now.
No, this is.
Oh, it's still gonna be his problem?
Yeah, it's still
Okay.
his problem, not my problem.
Might want to text him a picture of that stuff.
How fast have you seen that pop up fetish with? Because he said that he installed it a month prior to this happening.
That's quick.
Yeah.
Again, usually it takes a while.
Yeah, we were there. He said a month and a half after install. Like there was, the machine was clean.
That's a little fast. So, we did do one thing, and I'll show you the older pot. The older pots had a completely round
Versus 11 now.
stem to the potentiometer, and the gear was also round. So there was some ability for the gear to like slip on the potentiometer. So since then we have turned to the stem is now at like D, right, where there's a flat on the stem. So now there's a flat on the stem. The gear has a flat in it. So now the gear and the stem are mechanically locked together, so that the stem and the gear have to move at the same time. Okay. The other thing for you guys who are still thinking about, when you look at all of the vertical pots, all of the tracks are pointing in towards the machine, and it's really hard for dirt to fall on something that's technically the vertical track is actually, the gears are horizontal, right? So it's hard for dirt to fall into. On our horizontal potentiometers, we were actually smart enough that we put the track in upside down so that the gear is below the track, so that way dirt doesn't, because if the gear was up, I could see dirt and stuff getting on, but we put the track on the bottom. So on a horizontal pot, the gear's riding underneath it, moving this way underneath it, again for dirt and stuff like that. So there's only there's one or two ways for an arm to actually cause the pot to skip. We'll get into that not now because it's a different part of my spiel. But if you have a pot and it's more than a month old, it is more than likely just got too much resistance on it because we didn't start gold plating the pins either. Why cost us money if you can buy that for $5 and do the work for us, right?
So it'd be a safe bet just to go ahead and spray your connectors before you change the pot out. So.
Oh, you should always, yeah. Like you guys are gonna get a pot in your initial stock order, and you probably won't use it for over a year. Now, pots do go bad. Pots, they get gritty, right? And they get hard to turn. So you'll actually get a bad pot every once in a while. But the frequency of replacing a pot every 6 weeks is now.
Is this something we install or plug in when we are putting the machine together?
No, they're all put together. Some people ask if they should spray it from the factory, and I just tell them no. Just wait. And then some people ask me if I do, it's like if I do one arm, it's like if you're gonna wash my feet, wash all of me, right? It doesn't, you don't have to. So you usually just spray whatever pot's affected, right? Because the other pot's fine.
Did you have to simulate that, or did that happen organically?
I know I have to simulate that. So basically, I pulled the pot away and I spun it up to hit 400 so that I could simulate resistance. Okay. So what I'm gonna do is I'm gonna go back there and I'm gonna pull the pot away and I'm gonna spin it down and I'm gonna simulate using the CRC 226. So I'm actually on the screen. So the other thing I do is when the back is off of this part of the screen you get to.
Speaking of precious metals, silver's almost $90 per year.
That's a case, you don't want a case. So, it's at 304, 305. Alright.
Now's your moment.
Okay, so if you notice, it was calibrated at 300. The closest I could get it was 305. Okay, but also when I did tools clear, everything tools clear. I didn't get an error message right here, right? What you guys don't know, because you haven't been told yet, is that each tooth is worth 15 counts. So as long as I get it within that 15 count window, it's good enough for horseshoes, hand grenades, and nuclear war. It doesn't matter if it's a horizontal or a vertical potentiometer. Each tooth is worth 15 counts. Count is just a count. Okay. So again, that's why 305 is it's within the 15, and this machine is now going to work. We always say working as designed, right? You never say normally. You always say working as designed. Right? So we do a tool clear. Let me get back to. Alright, now we can go into data display. We can talk. And I'm going to try not to dribble this out too bad because it can get really dry and most people's eyes roll up into the back of their head. But if you don't understand this and you don't get this, you're going to have a very long, decrepit career trying to fix Revolution tire changes. Okay? Because it's very advanced and because there is one camera on that machine, but that camera is focused on the upper demon head so that we can see if the customer is doing something stupid. Maybe they're moving an arm at the wrong time or something, so that when they call up, because every customer is always going to call up and go, I just broke 8 TPMS sensors in a row, you owe me $800. And it's like, well, I get the first one, but the next 7 are probably on you, right? Because one's a mistake, and the other 7 are like, that's just someone being stupid, right? I broke 1, let's see if I can break it. Hey, I broke 2, let's see if I can break another one. So, but they'll call you up. They won't call you up on the first one. They'll call you up later. They'll call you up on the 8th. I did 2 whole sets and I broke every single one of them. That's a you problem. You're an idiot. But good luck explaining that without saying those words. So anyway, that's why we have, because sometimes people will move an arm in or they'll adjust something, and then so what we're trying to do is we're trying to see why the TPMS broke. So the only camera on there is actually facing out, but we don't have a camera. The other day when I changed that tire, when there wasn't a tire on the rim, that's because the machine has no idea if there's a tire on it at all. The machine has all of these steps, just like the retractable sunroof, right? It has to hit step 1, step 2, 2-step, 3-step, 4. 255 steps later, it goes from fully closed to fully open, and the thing comes back down and hides it, and then you're driving around in the sun. But it has to hit all of those steps, right? So that's there's no difference. The Linux operating system is programmed in meticulously, after about 6 years of R&D, that it has to do these things, and when it does these things, and you actually had a tire on the rim, it took it off and put it on. But again, there's nothing in there. There's no imagery that creates a 3D image. It's just literally relying on the potentiometers for feedback as to where the arms are. Okay? All right, so we have 3 different columns. I'm not going to go over every single, so I don't have to go over all 69 of them, but I am probably going to hit 58 out of these 69 numbers. Okay? All right, so I have 3 different columns. On the left-hand side of all the columns is always a count. And most of the time I care about counts because, again, I need to know where home is. If home is right, everything else past home should also be right. You will never hear me say, hey, what was the max on that? Right? The max is always dependent on what home is. Okay, so if you notice there's another column, there's a column over here to the right, a column over here to the right, and a column over here to the right. So right now I'm going to take 59, I'm just going to jump all the way to this one. I'm going to take motor current. I have no idea what 9 counts is, but I do know what 0 amps is. Right now we don't give these the number, you just have to deduce what they are. So if I go step on the pedal over here, when this thing's running, it's pulling about 16 amps. When I max it out, it's going to go up to about 26 amps. If I do that, about 16. About 25, whatever. So, again, counts are, to me, I don't know. I surely know what amps do, right? So I'm gonna look at amps. Okay. We're gonna skip a crowd. I'll come back. Air temp. I don't know what 184 counts of air temp is, but I know it's 76 degrees Fahrenheit, right? So it's about 71 in the room. You got electricity on a green board that's actually taking an air pressure measurement and turning it into it. So I can give it a couple of degrees leeway, right? It's probably 76 inside that circuit board. So I know 76 degrees Fahrenheit. Another one, spindle tilting. I may not know what counts is, but I know 90 degrees, right? So this is 91.5 degrees. Right, so I know what 91 degrees on my axis is. So, and then these are all in inches. No, you can't change them into millimeters. We've never been able to do that. It's always been inches. I don't get it. Especially since we ship to the rest of the world, and the rest of the world does stuff in millimeters. It's always inches because this got us to the moon first. So everything is in inches. So if you look at upper roller horizontal, it says 1701. So if you take an imaginary line and you put an imaginary line in the middle of the spindle and you measure from here to here, that's going to be about 17 inches. Right? Upper roller vert says 22 inches. So if you took the same imaginary line and you have this stick at the top of the platen and you measure from here to here, that's going to be about 22 3/4 inches. Now obviously if you bring it all the way in and all the way down, you can get it to 0 and then it'll be a lot easier to see. But just know that you can actually turn those numbers into something meaningful as long as you know what they actually are. Okay? These numbers on the right, aren't for the machine. These numbers on the right are for you. And the machine only cares about the numbers on the left. Everything has to be a count. Everything has a range. That's either going to be too hot or too cold. It's going to be 300 or not 300. Okay? Alright, so we're going to run through this. Let's see how I do. Alright, you ready to write? Alright, so actually he's just going to transcribe it, so no one's going to write anything down. You're all just going to be lazy and you're going to count on Steve's iPad there to not do anything stupid. So that's trust the Surface Pro. I don't know if I trust the Surface Pro. Alright, so for Steve's Surface Pro, here we go. We got 1, 2, 3, 4, 6, and 9. And if you notice 1, 2, 3, 4, 6, and 9, personally, I like them all to be 300 plus or minus 15. Okay. When you look it up in the service manual is going to tell you 300 plus or minus 100. You get that home number at like 200, you get that home number at 400, the machine is going to act dumb. It's just not going to work right. So I'm a 300 plus or minus 15. This one over here is at 278. It is just a hair out of my comfort zone, but that machine seems to be working okay, so I leave it alone. For whatever reason, the person that did mount head horizontal hates us because it's 1100 all the time. It'll never be 300. Unfortunately, the gentleman who designed it retired before I could ask him, but for some reason, the horizontal mount head is always 1100 instead of 300. I think he does it just to keep us on our feet. I don't know. Okay. So that's 5. Again, 7 and 8. 7 and 8, the press arm shoe. 7 and 8 are my linear actuators. So my linear actuators, again, because when I hit tools clear, it only moves hydraulic pieces and not electric pieces. So 7 and 8 are always just going to be wherever 7 and 8 are going to be. Right. The only thing I care about 7 and 8 is that they're relatively close to each other. I don't want one at 700, and I don't want the other one at 400. Right? They should move together as a pair. The linear actuators, of course, they have coils of wire in them, so they have a little bit different resistance value. So this one's 342 and 322. They're close, right? They're moved. You're not going to see them staggered like brake plate bits, right? You want them to be even. Okay. So whatever these numbers are, as long as they're close together, I'm around.
Is there a limit on how far away they can be, like within 50 or so?
So on that other screen, it was like 61 and 62. That's going to be the minimum. When you calibrate it, there's a minimum, and then the next step is you run them all the way out because the machine needs to know what it's working with, right? But whatever that number is, I don't know it. I've never done it. I don't really pay much attention to the pushers. Usually what happens with a pusher is if something goes wrong with a linear actuator, the one arm keeps moving and the other one doesn't. And then you're like, well, time to put in a linear actuator. So that's literally how hard it is to diagnose a linear actuator. Did it move? No. Get a new one. Put a new one. The other good news is both linear actuators are the same part number. So if you have one, there is a calibration point in that. Like I said, when you're doing the pusher, you have to pull them all the way in, and then you're going to take it, you're going to put it all the way counterclockwise, and you're going to bring them all the way out. That lets us know what the potentiometer in the top is doing as far as home and max, and then we do home and max on the arms, and then we store all of that. Okay. Press arm vert. Press arm angle, number 10. I'm fairly certain that's supposed to be around 450, but this machine keeps moving. Number 10. Number 10 is if I do this. Remember the other day? Yesterday? Yesterday it was asking us to put it here directly across for for pushing down on the top bead when the tool hook was coming out. And then also yesterday it was asking us to put this all the way around here when we're going to mount the top bead. So demounting the top bead is here. Well, that's how we know whether or not these things are in the right spot, right? We calibrate it here, we calibrate it all the way around to here, and then because it's in a circle, nice pie, we know what this number should be, and we know what this number should be. If you're in that room and it's quiet enough, there's actually a dinging noise. And when you bring this thing around, that dinging noise, there's not a dinging noise, and when you pull it around, there's a ding. It's almost impossible to hear. Right? You'll never hear it in a work environment. But it's an audible thing to let you know that you have it in the right range. Okay. So number 10, If you notice, I can move this one because the potentiometer is not hooked up to the wheel, the potentiometer is hooked up to the pusher shoe. So it goes from 605 all the way around to about 1250. Okay. Now there's a dog leg on here. I can't pull these together. That's why in the beginning this one moves out first because it trips the dog leg, and then I can bring it around. And it doesn't want these two to be together when it's putting the tire on. It needs them to spread out. Just like when we were using the V-tail depressor, or when we had the upper roller, and then we had the pusher, the VP arm, we spread it out as much as we could to make sure that the tire went into the drop center. That's what number 10 does. Okay? I want you guys to skip over to number 25. If you notice, number 25 right now is 0. And if I pull this out a little bit, it goes to 42,947,672. Okay? That number there will do that the whole way I turn it around. If you notice, the bottom number is 77, however. Right? So if you notice though, when I come back, it's not 42,947,000. Okay? That's something that's been in the software. That's something that's still in the software. If you go to 1.9 software, and you start to turn these in a counterclockwise direction, it's going to read 42 million. Right? Don't try to fix that. Leave it alone. Smarter people than you have tried. They have obviously failed. So all you care about is that bottom number, right? 7980. And then when I start to pull it back, it's just okay. So 25 is fun. 25 shows you that even engineers fail and they can't fix it. They'll probably blame it on something. I don't know. I just tell people to just totally disregard 25 most of the time. Spindle direction. I either have a 0 or a 1. So on 11, that tells me whether I'm turning clockwise or counterclockwise, right? Usually I think 0. I don't even know, but I either get a 0 or a 1. That lets me know, am I doing this or am I doing this, right? That's easy. Okay. Spindle counts. Spindle counts. I'm actually counting the holes in my wheel encoder. Okay. There are. You ready for the math? There's 128 holes, but because I have 2 different channels, somehow the 2 different channels, you take 128 and multiply by 4, and you get 512. That's engineering. I guess because it could go this way or this way, I'm not sure. But if you spin this thing slow enough, you can actually watch the pickup board as it's counting the windows, right? It'll start at 0 and then it'll go all the way up to 511, and then at 511 the home pulse will flick, and then it'll go back to 0, and then come all the way back down. So just like in a balancer, when you set the TPMS, we are literally just counting windows to the home pulse. I'm 72 windows to the home pulse in a counterclockwise manner, or I'm 400 and whatever to the home pulse in a clockwise, and that's why it always remembers where the TPMS is. That's why if you're having trouble with that, if you get dirt or you get fluid on the ABS wheel encoder, it can't count the windows, and then it doesn't stop the TPMS in time, and then you owe the guy $800 because you broke 8 TPMS. On the gas, baby. Changing tires. Joysticks, they're going to be what they're going to be. We're just trying to figure out where the middle is. Going to have to get with the program. PS controllers, you can push them up, down, left, or right. Most people have them done with rubber bands for quicker return because they're dying in whatever Halo game you're playing. So you got to get back to the middle. We're just trying to figure out what that middle is, right? So we figure out what the middle is, and then we figure out maxes in each direction. So, but we need to know what neutral is, right? Because this spring may push a little further down than this spring is pushing a little further up. So neutral may be just a little bit down because of spring tension. It might just be a little over, just depending on spring tension. Okay, so we're always just trying to find like an average, because otherwise the machine's gonna do something unexpected because that number's not where it's supposed to be, and then something's gonna. Okay.
Other connectors and joysticks interchangeable.
The joysticks, I'll show you. I have a board to show you. The joysticks are soldered onto the board. There's only one big connector. It's just like a 14, 16 pin. Almost looks like a ATX power connector, 20 pin. It doesn't have 20. I think it's on that one. Be careful. If you decide you're going to be a hero and you're not going to shut the power off and you're going to replace the joystick board, when you unplug the joystick board with the power on, every single arm will move down and in hypersonically.
Don't look it.
At least hit the E-stop. But turning it off, unplugging it, and undoing the air supply is always your safest bet, right? I have never seen those arms move that fast in my life. Those arms move.
So not something you're not something you're willing to demonstrate.
No. I mean, I could because I know it's coming now. Right. The first time you do that, you don't know they're moving at hypersonic.
They move faster than the intended speed.
They do.
Yeah.
It is.
It doesn't have like a safety
They
factor.
don't. Well, the safety is you're supposed to shut it off and not be an idiot and do it with the power on. But we're technicians.
Yeah.
We're trying to get into that. We got to make that warranty time.
20 years they didn't like that.
So again, for your safety especially. Safety over here. You're gonna shut it down.
You get a 1, 2, 3 uppercut.
You're gonna shut it down. You're gonna unplug it. And you're gonna remove the air hose from the wall.
You never go with it.
I got a metal splinter yesterday through those gloves. I'm like, son of a bitch, I can't win.
Which one bubble?
We're gonna
You'll probably be allergic to the plastic that the bubbles are made out of.
We're gonna see Jessica for the next name. He's missing fingers. Scars on his face.
So, anyway, all right. So joysticks are joysticks. I already did air pressure. So I'm gonna skip over to 23 and I have a rotate pedal and I have a tilt pedal. So 23 and 26 should be 1800 plus or minus 200 because it's a potentiometer and that's just the middle. Okay, now the other thing I haven't talked to you about yet is we have two different types of potentiometers. All of our arm potentiometers are what we call 10-turn pots, which means if you back it all the way up and you mark a gear, that gear turns 10 whole times before it gets to its other stop. The foot pedal and the tilt pedal pots are only 3-turn pots because I can't move that pedal nearly as much, so I have to create a bigger jump in my numbers from the middle, right, to either full on gas or full forward or full reverse. So my 2 pots on the bottom of the machine are 3-turn pots, and any other pot is a 10-turn pot. Okay, and you cannot fake the machine by putting a 10-turn and a 3-turn because it doesn't range. It was Friday. I was trying to go home. I learned the hard way. I learned a lot of things. Anyway, so that's 1800. That's 1800. My piezos, so I have a 21 and I have a 24. We were talking about piezos yesterday where they come down and they just sort of tap the machine. So I'm going to go over here to the upper roller and I'm literally just going to tap the machine like you're tapping somebody's forehead, like skip to the end. So if I do upper roller piezo, if you notice, I'm just barely tapping this. I'm not hitting it nearly. You can't even hear me hit it. And we're going from 1800 to about, what's that, 25, 26?
Yeah, I'm up 26.
Right, so it's, all right, then if I tap the lower one, it should be going to 0. Or what's it going to?
3,000.
3,000. Okay, so it is the same in either direction. It goes up, so it goes, the higher number is away. Okay, so again, I am barely tapping it because that's how sensitive a piezo is. That's why it's really important on that first move. You leave it alone. It's like your little sister with a lollipop. Leave her alone. Take the lollipop away. You know what happens. So, leave it alone. It has to find the sidewall. Okay, that's why on mine it was already broken down. When it found the sidewall, the sidewall was below the bead seat, and it logically was like, well, that's not supposed to happen. So it asked me the question: the bead's already broken. I had to be honest with it. I had to say yes. It's hard to fool the machine. All right, so piezos. Piezos are cool. We also have piezos in our balancers. We use piezos in our balancers for tub expansion and contraction throughout the day, because as heat comes by or cold comes by the tub, it's not like you can see it, but it's added pressure. So we'll talk about balancers. Spindle. We need to talk about this a little bit. Should that spindle be at 90 degrees?
Nature.
Should it?
Like it is.
Plus or minus one.
So let me pose the question to you this way: is it more important that the spindle is straight up and down, or that the spindle is parallel to the body of the tire chain?
Straight up and down.
Parallel.
All right. So what's that tell me? Why, if I'm at 91 and a half, my floor is not flat, right? My floor might, and if it's sloping to a drain, that's going to be crazy off, right? It might be 95, 96.
spindle, not the
But
arm.
this.
Correct.
Got it.
And this, they have to be right, because if it's tilted out, then I'm gonna be breaking rollers, right? Because the upper roller's gonna go out too far, the lower roller's gonna come right up into the middle of it, or tilted in. My upper roller's not gonna. My upper roller's always gonna be right, but then my lower roller's just gonna ride up the side of the tire and then, break the sidewall of the tire. So it's not critical that it's 90, but it is critical that it is parallel. And then again, everything after that is the floor. Right? So my floor over there, it is a finished concrete floor. It's got about 1.5 degrees of, whatever, and no concrete guy on the planet's gonna say that that's not good enough. Concrete guys have it easy. Steel guys have it even easier. Steel guys have it plus or minus half inch. Talked to a guy one day, he was making steel railing. He was putting in a safety railing while we were doing a rack. He's like, "What's your plus minus?" I'm like, 3 mil. I'm like, "No thanks." I'm like, "What's your plus minus?" Half inch.
Elevator.
That's not gonna work.
64. Elevator mechanics are down to 64.
I know.
These are all wide open houses, man.
I actually had an elevator mechanic. Was it the last class or the class before? I'm just asking that rhetorically because you can't tell me. But the reason he didn't like it is because he was always alone. He didn't see anybody. He was always in the elevator shaft. He became a hunter type. And I forget where he's from. I can't remember who that is. Yeah, I actually had an elevator type shop. It was crazy. It had some interesting stories. So again, X, Y. What's funny is I get a Y, but I don't measure it, and I guess because it's a gyro, so the gyro is measuring X and Y anyway. So we're going to give you the Y, but we can't do anything with it. All we can do is the X. I don't get it. Pulse width modulation stuff I don't care about, because we'll get into that when we get into the valve block, solenoid block.
So the spindle tilt is a gyro, it's not a encoder.
Correct. The tilting is a gyro.
Okay.
Yes.
And that's why the floor matters. I was kind of curious about that. Like, how does it know? So I was assuming it was an encoder. I'm like, how does it know?
Yeah, how would
what
it
the floor
know that,
level
right?
is?
Yeah, no.
All right. I was
Like
gonna take your word for it.
It's like the shadow. It knows. It's a gyro. And on that one it's kind of weird because the gyro is actually 90 degrees. It's not flat. It's like a baseball diamond. It's kind of crazy. They actually have it not. I don't get it. It's weird. Spindle RPM. That's just how fast you're on the gas, right? So you're either going slow or fast. 35 and 36. I'm going to tell you 35 and 36. I'm going to say this, and then you guys are going to immediately forget it. The 35 and 36, while you're going to do calibrations on those two machines, because I got 10 people, we're going to put 5 and 5 because I have 2 cal tools. You guys are going to calibrate both machines in ops. 35 and 36 are going to make you look stupid, Cause you're gonna get to a point where nothing's gonna move. But because you're in calibration mode, it doesn't give you any errors or any indications as to why it doesn't move. It's up to your brain to remember, hey, nothing's moving. That's because the machine thinks my tool hook is down. And logic dictates if my tool hook is down, it has to be down at the worst possible time where it's all the way down and it's hooked up to a tire. And if I move this arm away, I'm gonna rip the tire, hurt the rim, hurt the machine, hurt the operator. We're gonna do some damage. And we try to keep litigation here to a minimum. So, logically states if I am not all the way up, then I don't know where I am. If I don't know where I am, that is not good. So I just sort of, it's like red light, green light. Red light comes out. Nobody moves. All right. This is going to happen usually while you're tilting the spindle. Okay, so all of my cylinders are double acting cylinders, but the returns for all my cylinders go into one hose. So sometimes there's a little negative pressure that's applied to the other cylinders. And because of that, because of the way my tool hook is, the negative pressure on that cylinder allows the tool hook to drop. If they'd have made the cylinder this way, then the negative pressure would keep pulling up, but they didn't realize that that would happen. So the negative pressure will actually pull the tool hook down a little bit. Okay. There's a micro switch on the end of a rod. So there's two micro switches, right? So this is all the way up. This is somewhere in between. This is all the way down, right? So this 36 can go from a 0 to a 1 if it's all the way down. But if it's like this, then I'm somewhere in between up and down. I don't know where I am, and that's not good. So I have to get it to pull back up. That 35 will turn back, because then I have two zeros at that point. So then if I move it like this, the 0 goes to a 1. It knows that it's safe because my tool hook is in all the way up position, and then you can continue on with your calibration. That is going to happen.
You just do that with your hand?
No, so right here, it says tool hook down, tool hook up. So now, unfortunately, in a calibration, what stinks is you have to exit completely out of the calibration to get to the tool hook, to get to the tools clear button, because the tools clear button not only pulls all the arms up, it also pulls up the tool. The other thing on the main screen, there is something called advanced controls, which you should never get into. But one of the things in advanced controls is tool hook. And then if I want to, I can take the tool hook, I can make the tool hook go down, I can make the tool hook go up. Okay. So that's like the only way to make the tool hook go up and down. You can't just Steve. The rest of you guys who are like me have olive oil complexion areas, we're not making that tool hook go up. So it's just easy. It stinks because then you have to restart the calibration. Whatever you're calibrating, you have to restart that calibration all the way from the beginning. It'd have been nice if they put a little button over there that said the tool hook, tool down, but they don't like it.
So you just start out putting the tool hook up before you calibrate?
Yeah, but you're gonna be, you'll forget. Trust me, everybody forgets. So tool hook, tool down. Don't care. Already talked about that. Don't care. Don't care. Don't care. All right. So the only other thing I got to do is upper arm switch and the tilt switch. Yesterday, that last tire we did.
That
was the
19.5?
reverse mount.
Oh, no, the reverse mount. Okay.
Right. I don't know if you guys noticed it, but Steven was lowering the arm down, and it beeped at him, and the arm stopped. That's because the tire was big enough in diameter. The spindle was trying to push the tire into the floor. That activated this switch right here, and it caused the machine to stop. Because if you have a big enough, like we put that 28 on there, and you had a big enough, and the spindle tried tilting is not up to the job of tilting a 1,600-pound machine like this, so that bracket rips. And then we have a repair kit for it, because we don't want to replace the whole entire. Because if you're going to replace the whole entire frame, someone's getting a new machine. So we came out with a repair kit in case that bracket does start ripping. But that's why that switch is there, and that's why when you tried to lower that wheel down, it got to a certain point and you heard it and then it just didn't go anymore.
Right.
That's the machine saving itself by that tilt switch. Went from a 0 to a 1. Alright? Let's not do that, right? Arm switches. So somebody asked me yesterday that a 17-inch rim, and they said, was it customary for the arm to come out and touch the rim? And I said, yes, if it's a 17, if it's a 16, a 17, or a 19, because we're trying to figure out if the rim is a half size or not, right? Because we put on the right tire. I'm gonna go here. Alright. Back to here, go back to here, go in here. Right. Hey, that was supposed to stop. Oh, I know why. Do you know why it didn't stop? What happens when I'm in data display? I have no safeties. I'm the safety foreman in data display, and I'm a horrible safety foreman. So, if you saw, I really pushed that thing. Okay, so if you notice 56 here changed from a 0 to a 1. In normal usage, not in data display, the 0 turns into a 1 so that the hydraulic ram stops pushing the disc. Because at that point, because again, I don't know where the rim is. I mean, I know about where the rim is. I know where the rim edge is because I set the rim edge, but I don't know where the bead seat is. So that there's a switch back here behind a very big spring that you're all going to try to get Steve to compress. Move it a little bit of a shot. The hydraulic cylinder is trying to push the arm out. When the arm stops and hits something solid, the spring collapses and that switch turns from a 0 to a 1. Turns to a 0 to the 1. It tells the machine, hey, I've hit something substantial. We should probably stop pushing, because if we don't, again, we're going to break the machine, break the roller, break the rim, do something silly to the tire. So let's not ramp up more pressure at this point. Okay? So that's how it knows where it actually found like the bead seat. That's why when it came out the other day and just sort of flipped it, because it was pushing out, and then that 0 turned to a 1. It was like, oh, I found the actual rim diameter. And then I think it gave you the warning message, and it said, warning, this tire might be a 17 and a half. Probably because it was reading in the 17 and a quarter range. So again, we have to go to the bad part. Right? We can't, if we fall into the good part, then people are going to get hurt. So we always fall into the bad part and go, please double check to make sure that this isn't a half size rim before we put a tire on. It's going to be very bad for existence around it. Okay? But those are switches. There's an upper switch and there's a lower switch. And again, all that does is it says, hey, I actually hit my bead seat. Now I don't have to go in anymore. Now I can just come down. So during the bead baking, that's like the Leering Center up in Minnesota, the Quality Leering Center. That one was free. So during the bead braking system, the thing comes up and it etches up, it hits it, and then if you notice, it knows to stop, and then it just starts pushing either up or down to break my beads. Okay. And that's how it does it. We're gonna do this, we're gonna do this, we're gonna do this.
Actually get bumped
just a
the
misprint on the side.
I think I'm
Just to be
I think I'm
Oh,
done
got
with data. I think we all weathered through the data display spiel. Yeah. The reason there's an arm switch 1 and an arm switch 2 is because sometimes engineers over-engineer stuff. So the engineers wanted to make sure that the arm was all the way back in the beginning, and then the engineers wanted to make sure that when the arm came out, this switch opened when that switch closed, and then when that switch opened, this switch closed to make sure that that ginormous spring that came out of like a Ford F-100 from 1978 was doing its job. And then they realized they could save $1 here and $1 there, so they took them out. But because older software, we started out at 1.0. The cool thing about a Revolution tire changer is I can put any newer version of software into the very first number 1, number 2 Revolution output. So it doesn't matter what vintage your Revolution is, you don't have to worry about, is this the right version of software to go on that tire changer? You do have to worry about that on balancers. But on the tire changer, if we come like right now we're on 1.9, if we come out with 1.91 and you have a 2015 Revolution, you can put that 1.91 in that thing even though it's 11 years old. Okay? That's kind of cool. Not everybody makes their software. Okay? But that's why sometimes there's doubles, and that machine there doesn't have the double switches, but on the cutaway version that we're gonna break out, the cutaway version has the double switches, because it was pre-production, so it's like 2011, 2012. So that machine there is, I forget what year that machine is, that's an old machine. It's the only machine that I know of on this campus that still has a pneumatic cylinder and not a hydraulic. And we keep it that way on purpose, because never mind. So, that, and it's the only time you actually get to see a pneumatic cylinder, right? Because everything we've made since COVID has been hydraulics. So, all right. So data display. That was a lot of fun. I'm sure you guys are just enamored with it. I can see by the excited look in your faces that you want to know in the air about that. What time?
10 on the dot.
Right, 5 minutes.